Welcome viewers. As we are learning about the factors or determinants of organizational structure, today we will be discussing about the role of technology, how technology influences structure. And here we are going to define first what is technology, differentiate between three different kinds of technology which creates different competencies, understand how each type of technology need to be matched to a certain kind of organizational structure if an organization has to be effective. So, what we are basically learning is the role of technology in defining structure and how the structure will be efficient for each technology. Describe the contributions of researchers like Woodward. So, to understand what is technology, organizational theory researchers define technology as an information, equipment, technique, and processes which are required to transform the input into output. So, technology is the combination of skills, knowledge, abilities, techniques, materials, machines, computers, tools, and other equipments which employees use to convert or change raw materials into finished goods and services, or which is useful for the end users. So, mechanism or processes by which an organization turns its products into services. As we have discussed in open systems theory, there are resources which are procured from different means, like different resources, different say from the environment like land, capital, machinery, and those resources are transformed in various processes, the various processes of the organization, and which is resulting in the end product or the goods, services which will be consumed. So, technology has an important role to play in conversion of raw materials to finished goods and services. So, we are learning here technology as a core competitive advantage. Yes, of course, as we are seeing the transformation in organizations right from the Industrial Revolution 1 to Industrial Revolution 5, we have seen how technology has played an important role in conversion of the raw materials into finished goods and services. The input, conversion, and output process, let us understand, as the raw materials are procured in the input process, there is also use of technology. In the conversion process, there is a technology which is very inherent part of the conversion and output process, and till the time the finished good is produced. So, the technology of an organization's input, conversion, and output process can be a source of competitive advantage for an organization. How technology helps in organizational effectiveness? It is present in all organizational activities. Technology as an inherent part of organizational activities. So, in input process, it allows each organizational function to handle relationship with outside stakeholders so that organizations can effectively manage its specific environment. Today, we see the role of advanced technology like ChatGPT, or you have chatbots. They're all playing an important role. They are interacting with the clients or customers to understand about organizations. So, conversion is the process where transformation happens, transformation of inputs into outputs. Then, in the output that allows an organization to effectively dispose of finished goods and services to external stakeholders. Technology exists at every level. Technology at the three levels: individual, functional, and organizational level. So, we will be discussing about how technology affects organizations, its teams, and individuals differently, primarily by streamlining the various processes, enhancing communication, and enabling the data driven decision making at all levels. As we have discussed, that technology now it has transformed. There is data analytics, there is a use of artificial intelligence, machine learning, and cyber physical systems, which has helped in providing customers a unique experience. So, we will understand the role of technology at individual level, at functional level, and organizational level. At individual level, the personal skills, knowledge, and competencies that individual possesses. Uh, at functional level or departmental level, the procedures and techniques that groups work out to perform their tasks to create value. At organizational level, the way an organization converts its inputs into resources or inputs into products and services or outputs, like there are two ways. Mass production, the organizational technology is based on the competencies in using the standardized processes, progressive assembly lines process to manufacture goods. At crafts work, the technology that involves groups of skilled workers who interact closely to produce custom made products or custom designed products. So, use of technology at an organizational level, we see that an organizational level, technology drives strategic transformations, operational efficiency, and plays an important role in competitive advantage. In the automation and optimization, technology like robotic process automation, enterprise resource planning systems automate and integrate core business processes like the supply chain, finance, logistics, human resources to reduce cost and error. Data driven strategy like big data analytics and artificial intelligence help leaders analyze vast data sets to identify market trends, forecast sales, and make informed strategic decisions, leading to agility and adaptability. In flattened hierarchies, digital communities, and remote work technologies facilitate communication across various departments and geographical locations, enabling flat and more flexible organizational structures and empowering employees at lower levels. In customer relationship management, also technology has played an important role. Customer relationship management systems help manage customer interaction and streamline the sales and marketing efforts to enhance customer engagement, customer experience, and their retention rates. So, use of technology can also be seen at team level. Technology enhances collaboration, coordination, and project management within and across various teams, especially in remote or hybrid work environment. Today, as we are seeing, most of the work is carried out in hybrid mode or through online mode. So, technology is an important player in improving the teamwork or team processes or team effectiveness. Communication platforms, tools such as Microsoft Team, Slack, Zoom, or Google Team, or they facilitate real time communication or sharing of files and conducting virtual meetings, keeping team members connected, updated about information regardless of their location, despite geographical separation, people are still connected, informed, or they communicate with each other to improve the processes in the organization. The team effectiveness depends on the technology that binds people together. So, project and task management, how does it help? How technology plays an important role in project and task management? Softwares like Trello, Asana, Jira helps teams organize work, track progress, manage deadlines, and assign roles and responsibilities effectively. Earlier, the roles and responsibilities were assigned to team members based on like leaders' efficiency or leaders' decisions. But today, the softwares like Trello, Asana, Jira, they are helping teams organize their work, they keep track of the progress which has been done by the team members, manage meeting the deadlines and assigning roles and responsibilities. Collaborative uh, performance or collaborative workspace technology has also played an important role, like cloud based platforms, digital whiteboards, for example, Google Workspace and Miro enable multiple members to work on documents. People can be working on the same document and design and project simultaneously, fostering creativity and shared understanding. So, there is on real time, the teams can work on the same project with the use of technology. It also helps in knowledge sharing. Technology cannot be ignored for sharing knowledge and information across the team members. Intranets and knowledge management systems like Guru centralize company information, making it easier for the teams to find the information they need and reduce the communication overload. So, instantly the information is shared across the team members, and there is no more accumulation of information, or information is not withheld by one individual. Technology also plays an important role at individual level. For individuals, technology is primarily about personal productivity, skill enhancement, skill development, augmenting their human capability. How does it help? At what level technology helps in improving the human efficiency? Task automation, and individuals use personal productivity tools and automation. For example, smart assistants, email filters, specific software is there to automate routine repetitive tasks, allowing individuals to focus on more complex creative and strategic work. So thus it improves the human efficiency or their capability. Information access and management tools for data analysis and knowledge access provide individuals with information, necessary information to make better, faster decisions and improve job satisfaction. It also helps in improving the knowledge of the individuals, learning and development, continuous upgrading their skills and capability. Through e learning modules and online training programs, employees develop new skills and adapt to evolving job demands at their own pace. It is making the work more flexible and mobile. Mobile devices, remote access technologies enable individuals to work from anywhere. They can be at home and they can connect with people at their workplace, offering flexibility in working hours and location. So, what we have seen is how technology can influence or can develop capabilities of individuals. At an individual level, it has helped in improving the human efficiency. So, let us understand how is technology classified. So, there is a research conducted by John Woodward, and she has classified organizations based on primarily the production technology. She categorized firms into three different types of technology. One is unit or small batches, mass or large batch, and continuous process production. She has treated these categories as a scale with increasing degrees of technological complexity, with unit being the least complex and process the most complex. So, we have seen that unit or the small batch is the least complex, has the least complex technology, and the process or continuous process production has a most complex technology. In modern times, organizations have used these technology types and are reflected in different industries and their associated organizational structures. How do we classify technology and structure? Woodward identified 10 levels of technical complexity, which has been associated with three types of production, and the classification of firms is based on complexity of technology employed. Small batch or unit production emphasizes on small single units or small batches. Large batch or mass production, large batches of output is emphasized. Continuous process production emphasizes on continuous production of outputs. So, there is a routine technology which is like we can see that it goes with mechanistic organizations. If there is a non-routine technology, the organization has a structure of organic organizations or organic structure. Organizations adapt their structure according to the technology. This is what we will be discussing further, how routine technology goes with mechanistic or tall hierarchical structure. Non-routine technology, where there is a need for flexibility, goes with an organic and flexible organizational structure. So, carrying forward the discussion of how organizations adapt their structure as per the technology. Technical complexity, as we will be discussing the theory of John Woodward, we will understand what is technical complexity. Technology can be simple, technology can have moderate complexity, and technology can be highly complex. So, program technology is the one, the procedures of converting inputs into output can be specified in advance. Tasks can be standardized and the process of work can be made predictable. And technical complexity is the extent to which a production process can be programmed to control and predict the output. High technical complexity is where conversion process can be programmed in advance and can be fully automated. And the low technical complexity is where the conversion process depends primarily on the people and their skills and knowledge and do not depend much on the machines, or they are least dependent on technology or the machines. So, as carrying forward the discussion further, we will understand what is a small batch and unit technology. It involves making one of a kind, that is customized products or small quantities of products which are tailor made. The conversion process is very flexible, thereby providing the capacity to produce a wide range of goods that can be adaptable to individual orders. We can cater to an individual or a client specific orders. It is relatively expensive, scores lowest on dimensions of technological complexity. In jewelry designing, so the jewelries are made as per the individual's choice, or it is highly dependent on human and less dependent on technology. It caters to the individual's needs. Designs are made as per individual's choice. Large batch and mass production technology. It produces large volumes of standardized products, like we have toothpaste, we have soap, detergents. These are made in volumes and there is a standardized process of production. Conversion process is standardized and highly controllable. It allows an organization to save money on production and the charge a lower price for its products. It scores high on technological complexity dimensions. Then the third type of technology, where there is a continuous process technology. It involves producing a steady stream of output. Production continues with little variation in output and rarely stops. There is a continuous process of production, one after the other. It happens in one batch after the other. The process continues till the finished good is ready. Mass production tends to be more technically efficient than mass production. The technology used is mostly very complex and it is less dependent on human intervention. It scores high on technological complexity dimension. So, where is it used? For example, in manufacturing washing machines, manufacturing complex products like automobiles, where there is a continuous process technology being used. And technological complexity and three types of technology. So, small batch production, production of simple units to customers' orders, production of technically complex units, and fabrication of large equipments in stages, production of small batches. Large batch and mass production emphasizes on production of components in large batches, subsequently assembled diversely. Production of large batches assembly line type, which is resulting in mass production. And continuous process production, it depends on the process production combined with preparation of a product for sale by large batch or mass production methods. The process production of chemicals in batches, continuous flow production of liquids, gases, and solid shapes. So, there are three types of technology. One is small batch or unit production, the large batch or mass production, and continuous process production. So, when we see the technical complexity, the small batch or unit production has low technical complexity. Production depends primarily on the skill sets of individuals, skills, knowledge, and procedures. And when we see the continuous process production, which is highly or which has high technical complexity, the production depends primarily on the physical, on the machinery, the equipment, technology which is used, and on the computers. So, it is highly technical, technology dependent, and less dependent on human intervention. So, we are seeing that they have, each of them has a different level of, they are different from each other. Unit and small batch production. Let us understand how it is different from the mass production and process or continuous process production. Unit and small batch production, the technology involves producing custom made items in small quantities, tailored to specific customer specification. The structure is typically organic, which is flexible and adaptable, and custom software development firms, like companies that build software for clients, operate in a unit production model. Modern technologies like agile development methodologies and cloud based collaboration tools, Jira, Asana, allow for the necessary flexibility and constant communication to manage unique, non standardized projects. High end manufacturing, companies producing customs, yachts, specified medical equipments, architectural firm designing unique buildings, and they use unit technology. They rely on advanced computer aided design and 3D modeling software to create one of a kind product according to client's order. Like these days, the many companies like Godrej, they come up with the designs based on the 3D modeling software or computer aided designs, so that they can create a virtual model for designing the interiors, home interiors of the clients. So, to create a unique kind of product according to the client's orders. Surgical teams, the work of professional surgical teams, where each procedure is unique and requires high skills and adaptability, is also an example of unit technology in a service context. So, they use advanced medical technology, real time monitoring of equipments. Then, large batch and mass production. The type involves the production of large volumes of standardized products using assembly line and mechanized processes. The structure is typically mechanistic, that is formalized and centralized. It is tall and hierarchical with central control, and the rules are formalized, formal rules, regulations are being followed, and the organization has a centralized structure. In mostly used in automotive manufacturing, modern car assembly plants are the classic examples of mass production. They use sophisticated robotics and automation for tasks like welding and painting, high volume and consistency. The organizational structure is highly standardized with clear rules and procedures being laid down. Consumer electronic production, companies like Apple and Samsung, which produce millions of identical smartphones and laptops, rely on mass production technology. They utilize complex supply chain management systems and highly efficient automated assembly lines. Fast food chains like McDonald's and KFC, they have standardized processes of ordering and serving food in fast food restaurants. Is an example in a service context. Services example of mass production using digital ordering and precise operational procedure. Continuous process production. Let us discuss how it is different from unit and mass production. Continuous process production is most technologically complex. It involves continuous flow of liquids, gases, materials across the production process. It involves continuous flow of liquids, gases, materials across the production process, with most of the process being automated and run by machine. It is completely driven by machine. The structure tends to be organic with a focus on monitoring and planning by skilled workers. Planning and monitoring is done by the workers, whereas the processes are standardized. The structure tends to be very organic. Oil refineries and chemical plants, these facilities are mostly automated, and modern organizations in this sector use sophisticated operational technology with sensors, control charts, control systems to monitor and adjust processes in real time. Employees act as monitors and problem solvers. When the automated processes encounter some problems, there is a breakdown. So, employees intervene to overcome the errors or the problems, or to help to make the process system move faster. Electric power plants, generating electricity is a continuous flow or is a continuous process production. These plants use advanced process control systems to manage fuel flow and balance electricity generation with demands across the grid. Pharmaceutical manufacturing is also another example of continuous process production. Large scale production of certain medicines or vaccines might involve continuous process technologies that utilize high tech equipments, require continuous monitoring, and ensure quality and consistency. So, what we have discussed is technical complexity and its relationship with organizational structure. An organization that uses small batch technology with production depends on skills and experience of people working together. As a result, it is impossible to program conversion activities. An organic structure is most appropriate. An organization that uses mass production technology, ability to program tasks in advance, allows the organization to standardize the manufacturing process and make it more predictable. A mechanistic structure becomes appropriate. Similarly, an organization that uses mass technology, the task can be programmed in advance and work process is predictable, controllable in a technical sense. Still, the potential of a major system breakdown, an organic structure is the appropriate structure for this technology. The task can be programmed in advance and the work process is predictable and controllable in a technical sense. Still, the potential of a major systems breakdown, an organic system is the appropriate structure for this technology. Technical competency and organizational structure, let us understand with certain structural characteristics and how it is different for small batch technology and mass technology, as well as continuous process production or continuous process technology. In terms of the structural characteristics, small batch technology, the level of hierarchy is small, span of control is also small, and span of control for first line supervisor, say for example, if we take one example where the level of hierarchy is 3, in case of small batch technology, level of hierarchy would be 4 for the mass production technology, and for continuous process technology level of hierarchy is 6. Span of control, how many employees the supervisor is able to monitor. If we take for the small batch or the unit technology, the number of people is 4. In case of mass production technology, 7 employees can be supervised by the boss or the supervisor, and for continuous process technology, 10 people can be supervised, which means that there is less supervision required with increase in complexity. Span of control of the first line supervisor will be 23, and mass production technology it will be 48, and for continuous it will be 15. Span of control for the first line supervisor. That means for mass production, because the processes are already standardized, rules are rules are well defined, so many people can be supervised by one person. And ratio of managers to non-managers, it is 1 ratio 23, and 1 to 16, 1 to 18. Appropriate shape of organization, the organization will have relatively flat with narrow span of control in case of unit production. In case of mass production, relatively tall with a wider span of control, and in case of continuous process production, very tall with very narrow span of control. So, what we are learning here is, as the technology moves from unit to mass production to continuous production, the type of structure becomes organic to mechanistic to organic, and cost of operation is very high in case of unit or small batch technology. It is medium in case of mass production, and it is very low for continuous production technology. So, Woodward's findings on technology structure and its effectiveness, what we have discussed so far, the structural characteristics and effective structural characteristics for unit production is low vertical differentiation, low horizontal differentiation, and low formalization. The structural characteristics for mass production is moderate vertical differentiation, high horizontal differentiation, and high formalization. In case of process production, the structural characteristics is high vertical differentiation, low horizontal differentiation, and low formalization. In case of the unit production, the structure which is most appropriate is organic, whereas in case of mass production, the structure of an organization would be mechanistic, because processes are well defined, there is high degree of centralization, there is high formalization. So, which requires a structure, structure will be mechanistic, and in process production, because of high vertical differentiation and low horizontal differentiation, there is a high technology which is, or technological complexity being used, and so the structure would be organic. So, this discusses about how technology and the structure are related to each other. For each type of technology which has high dependence on, or high dependence on the technology, and organization which are less dependent on technology, the structures would vary, they will not remain the same. Woodward's research on technology and structure relationship. A careful analysis of Woodward has found that, to conclude that for each category on the technology scale, that is unit, mass, and process, and for each structural component, there was an optimal range around which the median point that encompassed the positions of the most effective firms. So, what to conclude, effectiveness is a function of an appropriate technology structure fit. What we have understood from the discussion is, Woodward has given a clear indication that, based on her careful analysis, she has concluded that for each category of technology, complexity from low to high, that is unit, mass, and process production, or process or continuous process technology, the structural component, they have a different type of structure which varies from organic to mechanistic to organic structure. Further, we will discuss about technological imperatives by Aston Group, or technological determinants of structure, how technology determines structure. Aston studies on technology and structure refers to a series of research programs which have found that organizational size and technological context are key factors which have influenced the structure of an organization. So, technology and the size of organization influences what type of structure an organization would have. They have challenged earlier theories of Max Weber, suggesting that Max Weber's bureaucratic structure are not always universally efficient. Rather, technology is a major variable to shape an organization's structure and processes. Aston Group has carried out the studies in 1960s, identified relationship between the size and structure that were independent of cultural factors. Relationships were universal or modified slightly by cultural regions as we see the differences in culture, so that these relationship between technology, size and structure will vary based on the culture. There would be slight variation or modification. Aston Group was also known for operationalizing abstract concepts like organizational size and structure, measuring size by number of full time employees, and defining structure by distribution of units and positions within an organization. So, what we have understood is Aston Group has thrown light on operationalizing the abstract concepts of organizational size, organizational structure. So, if you are to define what is size, it depends on number of employees, full time employees who are working in the organization. And if suppose somebody wants to define the structure, it is depending on how many number of units an organization has, number of positions or levels within an organization. So, moving further in the discussion, the Aston studies were influential in the field of organizational theory, particularly because of their findings of how organizational size propose that organizational size is a primary determinant of structure rather than the technology, or more than the technology, size is the determinant of structure, such as the degree of formalization and specialization. However, the studies did not acknowledge the technology's influence, particularly on the workflow related aspects of structure. Now, I'll just focus on application of Aston studies, the practical examples illustrating Aston studies application in modern organizational context. Large standardized manufacturing plants like automobiles, assembly lines, these organizations typically exhibit high levels of formalization. There are clear rules and processes or procedures, guidelines being laid. Specialization, there is a division of labor for each department based on individuals' competency, the work is assigned, and defined hierarchy as predicted by Aston studies for large organizations with a routine type of technology. The technology in this case, that is assembly line production, drives the highly structured and predictable nature of workflow. Then, for large government and bureaucratic organizations like tax collection agencies, these entities are excellent examples of Aston Group's findings that sheer size leads to a high degree of bureaucracy with many rules, standardized processes, and formal documentation, regardless of the specific technology used for information processing. There is a need to manage a vast number of interactions, communication, and ensure fairness or compliance necessitates formal structure. Then there is decentralized IT consulting firms. Smaller firms like IT have a flatter organic structure with less formalization and specialization. Technology, that is collaboration software, communication tools, enables flexibility and remote work, reinforcing the idea that some type of non routine technology, like a more fluid structure, is needed. In the global multinational corporations, where classifications are based on the landmark studies of Aston Group to design structural classifications, helped explain how these complex organizations manage international operations. The structure in most of the MNCs need to be balanced global integration or centralization with the local responsiveness. They need to be decentralized locally, illustrating the complex interplay of organizational size, technology, and strategy. So, in a sense, Aston studies suggest that primary influence on overall blueprint of an organization is of course size, but the specific nature of its work. Like, there is an interplay of size, technology, and strategy in defining the structure. So, with this, what we have discussed in this, we have discussed about the role of technology in defining organizational structure. We have discussed about the different types of technology: unit, mass production, and continuous process production. And we have also discussed about the Woodward's research and Aston groups and how they define size is a better determinant of organizational structure rather than the technology. Lately, we have discussed that it's not just the organizational size or technology, but it's a complex interplay of size, technology, and strategy which helps in defining organizational structure. Thank you.